Okay, welcome everyone to a new week. We are halfway through the geometry unit booklet. If you've been following along, I did lesson 1 last week, and it was a fairly large lesson, so I broke it into 2.5. I think I'll do the same thing for lesson 2. It's quite a large lesson. So I think I'm going to chunk it a little bit, and I'm not going to talk about every topic in lesson 2 today. There are about 5 individual topics, so I'm just going to talk about 2 of them today. Lesson 2 is a regular polygon. In lesson 1, we just talked about 4-sided polygons. So we talked about a variety of 4-sided polygons. The common ones that you probably know quite well are squares and rectangles, but we also talked about trapezoids and kites. So you can look back at the notes for those. I published the notes as well as the videos. And I know sometimes the videos aren't the greatest quality, so you can always look at the paper notes as well and ask me questions later on online. But today we're going to talk about different shapes, not just 4-sided polygons, but we talk about, you can see on the page 8 that lists some common shapes. So we go all back to talking about a 12-sided anyway. That's the picture that we show. But the 2 common sides that we've talked about are the 3-sided and the 4-sided shapes. And those are familiar to you from past math courses as well, I'm sure. The 3-sided shape is the triangle, and we actually studied triangles quite a bit. You had a whole unit devoted in grade 11 to triangles, and then we just finished a unit on trigonometry, the study of triangles. And if you go back and look at those notes, you'll understand why triangles are so important. We use the properties of triangles to solve a lot of our problems that occur in our day-to-day lives. Squares and rectangles also have a huge place in just the regular shapes that we see around our world. Most of our houses and buildings are built with rectangular shaped rooms. Many of the consumer products that we buy are packaged in square shapes or cubic shapes or rectangular shapes. This is a type of shape that lends itself well to stocking and stacking items. So that's why a square is quite a common household shape. But we're going to talk about other sides as well. A 5-sided shape is called a pentagon. A 6-sided is a hexagon. 7 is a hept. 8 is octagon. That's probably another common shape of our stop signs on our streets. These are less common: a nonagon, a decagon, a hendecagon, and a dodecagon. And I'm not expecting you to memorize any of these. You'll always have your notes to refer to. Remember that. So no memories involved. But there are characteristics that are common to all regular polygons. Now, the word regular is a very important descriptor, because when we talk about a regular polygon, it's talking about shapes that are, this is very important, the sides are all the same length. Shape or a 6-sided shape where, hi Cynthia, where the sides aren't the same length. For example, we studied triangles that were scalene triangles with all the sides different lengths. But a regular polygon is all sides same length. So therefore, for a triangle, we know that it has to be an equilateral triangle, right? The equilateral triangle would be the only regular shaped triangle. So when we're talking about the regular polygons, that's where certain characteristics are common to the shapes, no matter what the size. And I'm going to talk about, today I'm going to talk about central angles and interior angles. And then I'm going to stop my discussion for today, and I'm going to divide up the work accordingly. So let's just move down the page. As the number of sides increases, the names for the regular polygons get weirder and weirder, as you notice, kind of strange. For example, a regular polygon with 100,000 sides, it's called a decimiragon, and I don't even know if I'm pronouncing that right. You don't need to memorize all the names, like I said. You should be familiar, though, with the triangle, square, pentagon. Pentagon is the U.S. national capital and where the president's offices are housed in the United States. That's called the Pentagon, and it's a five-sided building. Hexagon, that's a fairly common one as well, especially in the building trades. There's lots of, there's hex wrenches and bolts. Lots of them have a six-sided head on top, and octagon. So these are all words that we're going to, or all the new vocabulary, I suppose, that we're going to be exposed to in this unit. Central angle, interior angle, exterior angle, a diagonal, a line of symmetry, and then just number of sides. It's very important to be able to determine the number of sides of a polygon. And the number of sides is quite obviously just the number of sides that the shape has. And you can see the 8-sided shape, 1, 2, 3, 4, 5, 6, 7, 8. So it's the sides making up the shape itself. And a polygon, just so you remember, is a closed figure, right? It doesn't have any openings at all. All right, so I'm going to just talk about central and interior angles today, and then I'm going to assign you a few questions, and we're going to leave it kind of short today because there's too many concepts to cover in one day. So because we're going to explore what central angle means and what an interior angle means on this page, so central and interior, we just picked a pentagon. And the reason we picked a pentagon is we've already explored triangles at some depth and rectangles and squares, like the 4-sided shapes. So size would be the pentagon. This is a nice shape to kind of see, to, I guess, enter the world of polygons that aren't the regular shapes that you're used to. So we're going to demonstrate what a central angle is using a pentagon. Once again, pentagon is a 5-sided shape, and a central angle, which is what we're going to talk about. If you draw a line segment from each vertex, so these corners, same as with the triangle, right? The corners, this is called a vertex. Okay. So notice in a 5-sided shape, there is 1, 2, 3, 4, 5. So a 5-sided shape has 5. Now, this is kind of vertexes, but we don't say vertexes. The plural of vertex is a vertices. That's the plural form. I would understand if you said vertexes, but the proper terminology is vertices. So a 5-sided shape has 5 vertices, a 6-sided shape would have 6 vertices, etc., etc. So everywhere that there's a vertex, at every corner, we draw a straight line, a line segment to its center, okay? So this is like the symbol of some cars too, I think, like the Chrysler, I believe the Chrysler logo is this pentagon with each vertex being connected to the center. So when this happens, you can see that 5 central angles are created, right? So a 5-sided shape has 5 vertices, and these 5 vertices, when they're connected to the center, create 5 angles. 1, 2, 3, 4, 5. You can think of this as making pizza slices from a weird shaped pizza, right? That's how most people do their pizza slices, or cutting a cake, right? Cutting a cake or a pie. To calculate the size of one of the angles, you can use the following formula. And this makes sense If you remember that completely all the way around a circle is 360 degrees. So we're just, right? And that's from probably middle school or something, right? All the way around a circle is 360 degrees. So if we want to divide this circle, the 360, into 5 equal parts, that's what the formula would be. 360 divided by n, where n is the number of sides of the polygon. Okay? So this is very important. In this unit, n will always be the number of sides of the polygon. Calculate the size of the central angle in the pentagon and fill in the size in the diagram above. Okay, well, the size of each central angle is just 360 degrees divided by 5, right, for a 5-sided shape. So 360 divided by 5 gives us 72 degrees. And this is kind of, I mean, it totally makes sense. If you add up all the central angles in any regular polygon, you'll get 360. And that should make sense because you're connecting all the corners to the center, and the entire sum of all the interior angles of any regular shape is going to be 360. So for any regular polygon, to find the size of the central angle, you're just going to take 360 divided by however many sides that polygon has. So that's our first rule that we're going to learn today, our first law of a regular polygon. The size of an interior angle is 360 divided by n. And then now we're going to talk about, so that was those were right central angles coming from the center. That makes sense. Now we're going to talk about interior angles. They're different from a central angle, formed by two adjacent sides. Adjacent means side by side, right? So it's the angle created at each vertex. Okay, so the interior angle is the angle created at each vertex. Okay, I guess I could say an interior angle. So a 5-sided shape has 5 vertices. Remember, that's the plural of vertex. Therefore, it has 5 interior angles. Okay, and you can visually see them. 1, 2, 3, 4, 5. Cynthia, can you tell me how the quality of the video is today? It looks clear from my end, but I'm not sure if it's clear or not. So if you could let me know. All right, so how do I find the size of one of these interior angles? Well, there's a formula that we're going to use. The sum of all interior angles is, so we're going to do the sum first. So S standing for sum, the sum equals 180 times n minus 2. So this is just a formula, again, that you do not have to memorize. Of course, this year is completely different than most years, right? Because you're not going to have a final exam. But if you were, I just want to make you aware that all of these formulas occur on that formula sheet that I handed out. And this is the formula sheet that you would have got on the final exam. So on the first page of that formula sheet, you can see at the last half, it's got the sum of interior angles, one interior exterior, the central, and then diagonal. So these are all your geometry formulas. Okay, all right. Thank you. Not sure what's happening there. Thanks, Cynthia. Okay, so the first thing we do is we don't find the sum of one interior angle, we're going to find the sum. So again, n is the number of sides, so don't forget that. For this whole unit, n stands for the number of sides, okay? And S is the total of the measures of all of the interior angles. So what we do first is we're going to find the sum of all 5 of these, right? So for a pentagon, the sum of all the interior angles is, okay, so let's formula. The sum equals, remember that capital S is sum equals 180 degrees. That 180 is part of the formula, bracket. Okay, so for a pentagon, we know that the number of sides is 5. So I do 5 minus 2. Okay, so that's going to equal, now I don't know if you remember, but we always do brackets first in math. Now your calculator, if it has brackets and you know how to use them well, you can type the brackets in your calculator and then your calculator will just tell you the final answer. But if you're not that comfortable using the brackets on your calculator or they're hard to find, we do what's inside brackets first, and then we do the multiplication, right? So it's 180 times, okay, that's what that, the 180 beside the bracket means times. 5 minus 2, that's easy enough to do in our heads. It's just 3. So 180 times 3 will be 540. So all of these 5 angles added up together equals 540. Okay, hi Hadija. So Cynthia doesn't say it's breaking. She says it's the recording is clear and it's the upload. Okay. I'll just talk really slow, Hadija, so even if it breaks, hopefully you won't lose much. So let me know if it breaks a lot. All right, hopefully everyone's comfortable with that. I've done 2 things on this page. I found the central angle. So I just take 360 divided by the number of sides. And then now I'm talking about the angles on the corners. So how I do that is I just take 180 times n minus 2. And you'll get a bit of practice with this today in homework, okay? So that gave me 540. So the sum of all the angles in a pentagon is 540. And we're going to do one more thing today. I'm going to flip. So here's the last part of today's class. The size of one interior angle. Okay, remember there was 5 of them? So if we know the sum of all of the interior angles, finding the size of just one of these is straightforward. We divide the sum by the number of the interior angles. Okay, and the number of interior angles is equal to the number of sides. Okay. Just divide the sum by the number of interior angles. We just take our 180, what we just finished doing, right? 180 times n minus 2. We found the sum was 540, and then we just divide by n, okay? Another way to think of it, one interior angle equals the sum of all the interior angles divided by n. Okay. Calculate the size of one interior angle in a pentagon. Okay, so we just finished doing that, right? Remember, the sum of all the interior angles equals 540. So the size of one interior angle is, okay, so there's 5 of them, right, in a pentagon? 1, 2, 3, 4, 5. It would be 540 divided by 5. So 540 divided by 5 equals 108. Okay, so each one of these is 108. So 108, 108, 108, 108, 108. When I add those all up, those equal 540. And this is just your hint. You must find the sum of all the interior angles first, then find the sum of the individual one. So we just finished doing that for a pentagon. Let's try another side, another shape. Let's try the interior and the central angle for another shape, and then I'll let you do some work, okay? So let's try, I want to try a shape that we really don't. Let's try heptagon. Let's try this same assignment, or the same thing we were doing with a heptagon, okay? Let's look at a heptagon. So I'm just going to grab another piece of paper, and I'm going to use a heptagon. Maybe I'll do this. So we're going to do another example. Okay. Find the size of the central angle for a heptagon. And a heptagon is a 7-sided shape. Okay, and it's a regular one, right? So it looks like this. 1, 2, 3, 4, 5, 6, 7. So it has 7 sides, okay? Now, the central angle is noted as C. For geometry, the central angle is C. So C will equal, remember, the central angle would be if all of the corners, all of the vertices were connected in the center. I'm looking for this central angle. So all of the central angles add up to 360. So I'm just going to take 360, my full complete rotation, divided by 7. And that gives me, okay, so this time I don't get a nice complete answer. I'm going to get 360 divided by 7, 51.43 degrees. So each one of these, if I do this, if I I'm going to try and draw my a fairly 1, 2, 3, 4, 5, 6, 7. Okay, here's my seven-sided shape. Each one of these is 51 point, right, from here to here. Each one of those is 51.43 degrees. Okay, so that's the seven-sided shape. Central angle. Let's do the second part now. Find the size of one of the interior angles for a heptagon. Again, seven-sided shape. Okay, so this time I'm taking my seven-sided shape. So again, mine don't look that pretty, but okay, 1, 2, 3, 4, 5, 6, 7. They're pretty bad, right? Should have used a ruler. Now I'm trying to find the size of this. This is the degree I want. So find the size of that. So what I have to do first is I find the sum of all, the size of one interior angle equals, okay, the sum of all interior angles that's the first formula we learned about interior angles, divided by n, okay? So the sum of all interior angles, that means I take my 180 times n minus 2, right? That was the top formula. And then, of course, the bottom formula is just n. Okay? So the size of one interior angle. Okay, so let's finish this up. So for a seven-sided figure, this is going to equal 180 times 7 minus 2, all divided by 7. Okay. For a seven-sided shape, remember this, seven-sided shape, n will be 2, or sorry, n will be 7. Just like over here, n equals 7. All right, so let's do this. Let's keep going. Equals 180 times 7 minus 2. I can use my calculator or just know that in my head. It's 5 divided by 7. So 180 times 5 divided by 7. And that's going to give me 128.57 degrees. Okay. So the size of this angle here equals 128.57 degrees. And that's it. I'm just going to talk about those two concepts today, just the central angle, which is really, I think that's a pretty straightforward geometry concept. It's just going to be 360 divided by whatever your n value is. And then the second one, the interior angles were a little more difficult. And that's why I would always have the formulas in front of me. I'd always be looking at the formulas so I don't make any errors there. So let me know if you have any questions, and I'll tell you what I'm going to assign today. I'm going to take assignment 2, and I'm going to break it up a bit. So all I'm going to assign for homework right now is, and if you want to work ahead, by all means work ahead, but I'm taking this very slow, and I'm giving people chances to catch up on old homework too, because I know there's a lot of people who are just trying to get through old homework. So on page 14, page 14. I'm just going to assign number 1, A to D, and then number 2. And I'm going to stop there. So number 1, A to D, and number 2. And I'm going to stop for that. And then I'm going to, tomorrow I might even have a bit of another work period, so you can ask old homework. I'm trying to keep this at a very nice, even pace, so people with kids at home and other commitments they have can kind of keep up with us too. All right, do you have any other questions for the day? No other questions for the day? Okay, well then I'll leave it off. You can always email me later. Remember, I'm around every day, or almost every day, I would say at 10 o'clock in the morning for extra help. And you can always email me and tell me if you need help another time, and we can arrange something. Okay, I guess I'll sign off for the day, and I will talk to you either through email or talk to you tomorrow. All right, goodbye.